Hello once again. This is Space Nuts. My name is Andrew Dunkley, your host. Thanks for joining us. Coming up on this episode, we've got a little bit to talk about. They've been digging around on the moon. I know that's true. Humans have done it. But this is the case of ground-penetrating radar, and they've made some really fascinating discoveries about our lunar buddy. And Perseverance, which is sort of trundling around on the surface of Mars looking for, life, etc., has just taken a bit of a peek upwards and gone, oh, sunspot on the moon, heading for Earth. I better tell them. So we'll talk about that. And audience questions from Rusty, Rennie, and Cowboy, all coming up on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us to talk about all of that is Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. And just to, in case your intro there caused any alarm among our listeners, the sunspot is actually not on the moon, it's on the sun.
Oh, did I say the moon? That would be weird.
It would be weird, but sunspots on the moon, I don't know. I quite like the sound of that.
Yeah. Well, maybe in its turbulent past.
Yeah, it's in its turbulent past. That's right, which is probably one of the things that we'll get onto. So,
well, we might as well talk about it straight away and get straight into it because, it is our nearest neighbour, astronomically speaking, and we're doing a lot of stuff to get there. The Indians the other day landed there, and to much fanfare, I might add, they are thrilled. They are cock-a-hoop. The Indian Prime Minister's jumping for joy.
I think most the Indian population are as well. It's such a big deal, and it's fabulous and
Massive deal.
Rightly so.
And if you were laying bets like 50 years ago as to which nation would be fourth to land on the moon, you wouldn't have said India, I don't reckon.
No, and I think, if you'd put bets on who was going to successfully touch down at near the moon's south pole, you might have betted the opposition on that.
Yeah, absolutely. Well, Russia tried but crashed, and India slipped in as the tortoise in that particular race. But they're doing great things. But this particular story centers around China's exploration of the moon, and the Chang'e 4 mission continues to make leaps and bounds, which is very exciting.
It's a fantastic project, and I keep in my looking out on the news on the news sources and news wires, I suppose is the correct way to say that. I and often see stories coming from Chang'e 4 that they've little discoveries that always make you think, well, this spacecraft is doing great stuff. And actually, what's nice about our two stories today, Andrew, is they both come from rovers, but on different worlds in the solar system.
Yes.
And they're looking in opposite directions. Because Chang'e 4, as I think we've discussed before, has a ground-penetrating radar on board, as did its predecessor, actually, the one that broke down, and the radar worked very well, but the wheels didn't. That was the earlier version of, I think that was Chang'e 3. Excuse me a minute, I'm just going to bring it up.
You'd think with the fact that we invented the wheel so long ago, we'd be getting it right by now.
Yes. Yeah, that's right. It's probably the tyres on the moon's surface are a bit to take in there.
Yeah.
And yeah, we'll see how the Indian rover, which is already on the surface and doing great things. Anyway, back to Chang'e 4. So its ground-penetrating radar has sent back information over the 5 years since Chang'e landed. It's 2018 when that spacecraft touched down on the far side of the moon. Incredible.
Wow, that's gone fast, hasn't it?
That's fascinating, yeah. We've seen records of the strata down to about 40 meters so far, and that has told us quite a lot about what's under the surface. But there's been some new research which comes from a mixture of Chinese and I think UK scientists. The University of Aberdeen in Scotland is one of the participating organisations, as well as the Chinese Academy of Science and Shenzhen University. They have done some work tweaking the data, and they've now got a map that goes down to 300 meters below the surface. So that's extraordinary.
Yes.
What a way to do lunar geology, or selenology, it probably should be called. The study of the rock strata underneath the moon gives us insights underneath the moon's surface, gives us insights into what the history of the moon might have looked like. We've got a pretty good idea already from studies that have been done previously, including the idea that the moon came into being when an object that we call Theia, perhaps about the size of Mars, collided with the Earth in the Earth's very early history, something like 4.5 billion years ago. And that formed the moon. It's actually one reason why the moon is made of similar rock to the Earth, because a lot of it came from Earth. But there's also, we know that the subsequent history of the moon was pretty eventful, because at that time the solar system was a wild and woolly place with lots of things charging around and colliding with each other. And in particular, there's a feature on the far side of the moon called the Aitken South Pole Basin, which is a quite deep crater. It's actually, I think it's one of the biggest impact basins in the solar system that we can still observe. And that's obviously something very large, very early in the history of the moon, hit it there. But there have been other large collisions as well. And we know that some of those produce volcanic activity. So when you look at the moon, even just with the unaided eye, you can see the grey patches on it, which are what we call maria, the Latin for seas, because they were always called seas in the old days. And they are actually lava plains, mostly basalt, on the lunar surface. And they are basically filling in the dints in the surface that were caused by impacts. And so that's something that we observe on the near side of the moon. Now, Chang'e on the back side of the moon, looking down into a layer that is not sitting in it's not actually sitting in one of the maria, because there aren't many maria on the back surface of the moon. It's sitting in a plain, a relatively flat plain, but it's a different sort of geology. But what they have discovered is that round about 300 meters below the surface, you find essentially layers of lava. You find these lava flows that might mean that at some time in the distant past, there were what we now call maria, like the ones on the side of the moon that faces us. And there might have been those things on the backside as well, but they've been covered up by successive layers of material, which may well have come from the early history of the formation of the moon, because we think the far side of the moon has a thicker crust, and we think that's because in the early history, when the Earth itself was very hot, the side that was facing Earth got hotter, and so all the sort of rocky type materials, which were currently vapor at that time, they condensed on the cold backside, not on the hot near side, and making the thicker crust on the backside. So I think this kind of supports that view. So they've got 300 meters of various layers of material, including broken rock, dust, soil, that sort of thing. But then, and apparently there's evidence for a crater as well that is well below the surface, one that's been covered up, and the layers of lava at the bottom, showing that yes, there was volcanic activity certainly early on in the history of the moon.
So they've used ground penetrating radar and had a bit of a look under the surface, because up until now we've only really been able to scratch the surface, literally and figuratively. And they've found, not surprisingly, they've found rocks and soil and lava and a bit of the history. What might be further down inside beyond 300 meters?
Probably thicker layers of lava, because when they penetrated these layers of lava, which are probably about the limits of how far down they could go with these data, they found that the layers, as you get higher up, the layers get thinner, the lava layers get thinner, and so it's sort of, you can easily imagine that there were episodes of volcanic activity where things were pretty hot to start with. So you got lots of lava, and the fissures, the cracks in the ground were wider. You'd get more lava flows in the earlier time, and then as that was covered up, the lava flows would get steadily thinner as the temperature falls, and as the cracks in the rock close up because because of this cooling. So that sort of suggests that if you could look further down still, you'd find thicker layers of lava. And I don't know whether we will be able to do that, but I think these authors are fairly confident that we might get still more data from the Chang'e 4 ground-penetrating radar. So it's a really interesting page to watch, if I can put it that way, on the web to see what further we might learn from this quite remarkable little spacecraft on the far side of the moon.
It's really terrific, isn't it? They're doing great things. Are we likely to? Is the moon likely to have a core?
Yeah, we think it does. It's not really known what it is like. Probably cold, because the moon doesn't have a magnetic field. If the moon had a molten iron core like the Earth does, there will probably be more magnetism than there is on the moon. So the suspicion is that there is a metallic core at the center of the moon. That's the natural thing for any kind of planetary object, that the iron sinks to the middle because its own gravity pulls it down. So you get a metallic core, and iron is a very common element in the universe. So you get a metallic core. But as I said, the thinking is that is pretty cold on the moon.
Yeah. I mean, the evidence is suggesting that the moon did sort of get forged out of the Earth after the impact of Theia. There are a few other theories, like it was captured. One wonders what it would have been like had it been captured. We haven't dismissed that theory, but I think we've almost written it off. But if it was a captured object, it probably would be a very different object in comparison to what we've learned about the moon.
Yeah, that's right. So it was certainly, until the Apollo era, all bets were off as to how the moon was formed. Yeah. And in fact, a theory that owed its origin to George Darwin, who was Charles Darwin's son. George Darwin was actually an astronomer, and he was interested in the origin of worlds rather than the origin of species, like his dad. And he had this postulate that the early Earth was rotating so fast that centrifugal force pulled off the equatorial layers to form the moon. Now, that doesn't work because we don't believe the Earth ever rotated fast enough to do that. But once Apollo astronauts brought back moon rocks, and it was discovered that their sort of isotope ratios in the material of those rocks is identical with Earth, that said, okay, you've got an origin where the moon has come from the Earth.
Yeah.
And just going through the history of this a little bit, we've talked about this before, I know, but one of the problems with the Theia theory, or Theia you might call it, Theia is the name, and I think in Greek mythology, Theia is the mother of the moon, so that's where it comes from. So this body Theia, one of the problems with that theory is that in most collision scenarios, you end up with a moon that's made more of the rock from Theia than rock from the Earth.
Yeah,
that was always seen as a problem until it's probably about 3 years ago now. Researchers, if I remember rightly, they're in Japan. They pointed out that if the moon was, if the Earth still had a molten surface when the Theia impact took place, and it may well have done because it was very early in the history, it was probably the lava ocean period of the Earth's history, which doesn't bear thinking about.
No.
Then you splat this object into a wet Earth, and it turns out that theoretically then you can predict that you're going to get a moon that's made of Earth rock rather than Theia rock.
That makes perfect sense.
Yeah, so I think that's the current best bet for the origin of the moon.
Yeah, sounds like it. All right. We will watch with interest on the travels of Chang'e 4. But if you'd like to read up on that story, it's on the phys.org website. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
From one rover to another, Fred, let's point our investigative finger at the Perseverance rover on Mars, which has been moving around on the surface very successfully, looking for things that might one day tell us more about the red planet. But it just had a bit of a look around the other day and looked up and went, oh, there's a sunspot. Don't like the look of that. It's heading towards Earth. Because we can't see it yet, but they can see it on Mars.
Isn't that extraordinary?
I'm a bit annoyed that they didn't tell us sooner.
Well,
those pesky Martians.
Yes, it's Martians, otherwise known as NASA mission scientists, who are driving the rover. So probably a little-known fact about Perseverance. I guess we all know it's got something called the mast cam, which is a camera on a mast, as you might expect. An amazingly useful piece of equipment, and it's been used to photograph all kinds of things, including the Ingenuity helicopter. Great stuff. But also, every day, a photograph is taken of the sun by the mast cam. So it looks up every day to the sun and takes an image. And that's partly, it's to look at the sun, but it's partly to be able to sort of estimate the amount of dust that there is around them in the atmosphere. Because dust is always present on Mars. That's why the atmosphere is pink rather than blue, or the sky is pink rather than blue. And so, dust storms can be extremely difficult events on Mars because you get global dust storms. We had one, I think it was back in 2018, or I think it's 2018, the last big one, last global dust storm, which covered Curiosity with a lot of dust. Perseverance wasn't there then. So you're always on the lookout to see how much dust there is in the atmosphere, just so you kind of know what's coming. And in doing that, obviously, you get a collection of images of the sun. But on one taken recently, a very large sunspot group was seen on the solar surface. And so, the orientation of Mars with respect to the Earth means that we cannot actually see that sunspot because the sun's rotation hasn't brought it round to face the Earth yet. So now, by the time this episode goes to air, that sunspot might be visible, Andrew, and we'll know whether we're going to get solar flares and solar storms and the kind of things that sunspots breed. Sunspots are hotbeds of magnetic activity on the sun, and they're where solar flares originate. And that sort of event can throw lots and lots of subatomic particles at high velocities into the sun's environment, some of which might hit the Earth at some point. In which case,
and that's the concern, isn't it? Because with all the electronics we are so reliant on these days, a direct hit from a massive solar flare is not just going to be something that we can go, no big deal. It will be a big deal.
It could be, given, as you say, our reliance on electronics, particularly spaceborne electronics, because spacecraft are in low Earth orbit. They're still protected by the Earth's geomagnetic field. Once you get to geostationary orbit, though, you're outside that cocoon of protection, and so that's when you start worrying about your spacecraft electronics getting fried. And of course, even on the ground, you can get effects from geomagnetic storms. I keep talking about it. The event in 1989 when a geomagnetic storm kind of blew all the fuses in, I think it's Quebec province, if I remember rightly, and something like 9 million customers in Canada lost their power supply for several hours because all all the overload switches tripped because of the magnetism that these subatomic particles brought with them.
Yes, and there's been some famous cases. That one back in the early, when was it? Early 1900s, late 1800s, something like that, with the telegraph system.
Yeah, that's right. That was the Carrington event, which
That's
I think
right.
was 1860s.
Yes.
9 sticks in my mind. That might be the wrong date, but it was that sort of era. And you're right. It was the infancy of the telegraph, and a lot of telegraph wires burned out because the event was so strong. That was the strongest recorded geomagnetic storm in history. And it came from a particularly active region on the sun. In fact, I think a bright spot was observed in the sunspot at the same time, and that's where the name Carrington comes from, because I think that was the name of the astronomer who observed it. So the solar flare, which certainly affected planet Earth.
Yes, indeed. And the NOAA organization, the National Oceanic and Atmospheric Administration, is responsible for basically offering alerts for these particular events. And they basically continually update people that these events are happening, and they do happen a lot more often than we think. They just don't seem to affect us all that much, but they have had situations where there've been big blackout zones, and there was a case a couple of years ago where a big sort of chunk of the Pacific Ocean was blacked out, and they lost communications with everything that was basically on the water around that area because of what happened. So they're always putting out warnings, and sometimes they're small warnings, sometimes they're bigger. But it also gives people a bit of excitement too, because you might get some really good auroras to look at if it's sort of hitting the right part of the planet. But the big danger, I suppose, is that we will have a massive sunspot in direct line with Earth and a massive solar flare as a consequence. And that's the one that emergency services are really focused on. And they do a lot of, there's a lot of work going on these days to ready us for such an eventuality. Hopefully never, but it is happening in micro pockets, if you like, around the planet all the time. But what we're really worried about is a catastrophic event, something so big that it wipes out, big sections of a country or a continent or something like that.
Yeah, in terms of the power supplies and things, and the electronic. It's certainly true that protections are built in when people design these things. They know that there's, especially bearing in mind the Carrington event, which was something that I don't think it would be catastrophic today, but I think it would make an impact. It would certainly cause power failures and things of that sort, and it may damage spacecraft as well. A lot of satellites have at least one side of them hardened against radiation, so with thicker metal in their, in the chassis, the spacecraft bus. So you turn that side towards the incoming particles if you can. That's the way these satellite operators work.
We know the sun operates on an 11-year cycle, and it's been sort of going through a different phase recently, hasn't it?
We're coming out of a minimum, so we're sort of heading towards the solar maximum time when you do get more of these events.
Right.
So yes, that's correct.
Do we know why that happens? Why it cycles like this?
It was baffling until really quite recently, but there's now an understanding of processes taking place within the outer layers of the sun, and something called the solar conveyor belt, which is, if you imagine a fictitious conveyor belt running from the sun's pole to its equator, that is a magnetic phenomenon that carries the sunspots further away from the equator. It's been well known, probably for getting on for a couple of hundred years actually, that as the sunspot cycle goes through, sunspots appear at different latitudes. If I remember rightly, their latitude increases as the sunspot cycle goes through, and that's thought to be due to this conveyor belt effect carrying things under the surface. And it's all about magnetism. It really is all based on intense magnetic fields. So the understanding is still not perfect, but I think we know a lot more than we used to about this sort of thing.
Yeah. I was just having a glance at the Carrington event to try and learn more about it while we were talking. And what was extraordinary was the effect it had, not so much on the telegraph, even though that was a telling factor, but apparently it caused auroras that were so bright that it woke people up. The glow was so intense.
Yeah, that's right.
Can you imagine that?
Yeah.
And the auroras were seen at very low latitudes: Mexico, Cuba, Hawaii, Queensland in Australia, Japan, China. They all saw the effect of this one geomagnetic storm.
Yeah.
So it must have been intense. Can you just imagine that?
Yeah, being woken up by the aurora, that's quite an unusual thing.
Because of the glow. Yeah, it's amazing stuff. So, so with this particular hole that they've or sunspot that they've observed through Perseverance, how long will it take? Did you say to swing around and be visible to us?
Like a few days, a week, or something like that.
Oh, is that all?
Yeah, it's not very long.
Okay,
The sun's rotation is about a month. I think it's 27 days on the equator, if I'm not.
All right, quicker than I thought. Okay, so it is a good thing that Perseverance is there and can spot these things for us.
Right.
Not that we can do much about it, because if it turns out that this sunspot is going to be in direct line with Earth, well, we're just going to have to grin and bear it, and put our aluminium hats on.
Or paper bags. I should just add, though, Perseverance isn't the only thing that's looking at the sun from different angles. There's a whole flotilla of spacecraft which are specifically there to observe the sun. So they'll tell us more about it as time goes on. But I just thought it was really neat that we see from one planet a different view of the sun, and get a forewarning, as you said.
Absolutely, yeah. Space.com is where you can find that story about the sunspot. They've got a great photo of it too from Perseverance. So, and the mandatory red ring added to the photo, so you can see where the sunspot is, just in case you don't know what you're looking for. I think most people know what a sunspot looks like. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Okay, Fred, shall we answer some questions?
Oh, let's do that.
Or we'll just play them and go, I don't know.
Dunno.
All right. First one comes from one of our regulars. It is Rusty from Donnybrook.
G'day, Fred and Andrew. It's Rusty in Donnybrook. Fred, you seem to have some similar ideas that Adrian Berry expressed in his prophetic book, The Next 10,000 Years, which he wrote in 1974. Did his work have any influence on you? You seem to have some similar ideas there. Just wondering to what extent that might have been. Thank you.
Okay, yeah, thanks, Rusty. All right, well, he's kind of put you on the spot there, Fred.
Well, I can tell Rusty. The answer's no. Never heard of him, mate. No.
Oh, wow.
I know I'm very poorly read when it comes to things like that. I should check it out, though. Thank you, Rusty, for that. I'll go and have a look at a book. Well, 1974. That's a time when I was certainly very active in the space world. I was working at the Royal Greenwich Observatory in 1974 on planetary ephemerides.
Mm.
Do you know what they are?
No.
Tables of where they are, their positions. So the bit of the Royal Greenwich Observatory I was working at was called Her Majesty's Nautical Almanac Office, and it was formed in the Yes, I think it was might have been Halley who formed it.
Okay,
back in the day, we were all about planetary positions, about planetary orbits. So the research was, in looking at the orbits of planets and how they interact with each other. So that's what I was doing then. I wasn't quite. I was still switched on to media stuff a bit because we we used to get calls from people wanting to know what they'd seen in the sky and things like that, and I had a lot to do with that. But that book eluded me, so I will check it out. Thank you very much, Rusty, for pointing it out.
Yeah, I've just done a quick squiz for it. It's on all of the major book platforms, but it basically is Adrian's work in trying to figure out what might happen in the universe and so on for the next 10,000 years. And I suppose, we're only just a bit past the first part of that 10,000 years in real terms. So maybe not much has changed, but we've learnt so much in such a short time. It's possible that some of the stuff he's predicted might not have happened the way he thought. But apparently he passed away in 2016. But the next 10,000 years, a vision of a man's future in the universe is, could be a good read. So look out for that one. Now, Fred, we have another semi-regular in the form of Rennie, who has got 3 questions for us. Could have taken up the whole segment.
Hi, this is Rennie Trout from West Hills, California. I always enjoy each show. I have 3 questions, if you could answer, please. If the Earth was a moon, how different would life have formed on Earth if it was a moon? And any other insights into what the world would be like if it was a moon instead of a planet? Second question, will quantum computing give us any insight or maybe the origins of everything and make things clearer to us as far as the quantum world and larger masses that work with Newton's laws? And the last question is, could there be elements anywhere in the universe that are not on the elemental table? Thank you. Love the show.
Thank you, Rennie. I can answer the last one, yes, because they leave gaps in it on purpose just for that very reason. Is that right, Fred?
Yeah, although...
Potentially.
Yes. It's a really good question. That I mean, we're talking about the periodic table here, and my understanding is it's pretty complete.
Okay,
because there's a bit of history with this. Just answering Rennie's last question first, in that if we go back, 100 years actually, people were still baffled by the spectrum lines from nebulae. So nebulae, clouds of gas that are excited by usually a nearby star, causing them to glow with characteristic colours. And those colours come from the emission of light from elements at particular wavelengths. So hydrogen, for example, has a very strong emission in the red part of the spectrum. It's an emission line called hydrogen alpha, and then there's a whole sequence of them. Hydrogen beta is actually in the blue. Anyway, there was a line found in nebulae, which was a very bright one, a very bright green line, which could not be identified with any known element on Earth. So the way you do this, you look for things in space, and you can excite a gas on Earth with an electric current or something, and it glows with a characteristic glow. Sodium is the best known one. You remember the old sodium vapor lamps that have that orange, yellow? That's effectively a single line in what's called an emission line. Just emitting one characteristic color, and if you find that color in space, you know that there's sodium there. So they found this green line, but it was not associated with any known element on Earth. And at that time, towards the end of the 19th century, the periodic table was being built up, and there weren't any gaps. And that was why people were baffled by this, because not only did they not know what this is, they could not see any way in which an element could exist that could cause that line. They'd given it a name, by the way. They call it Nebulium. Nebulium was supposed to be this element that was in a only in nebulae, hence the name. Nebula as being a Latin word for mist. So Nebulium was a mystery, and it was actually a man called Ira Bowen, who was an American astronomer who in the 1920s worked out what it was. And it's actually, if I remember rightly, it's oxygen, which is behaving in a way that it doesn't on Earth because the pressure is so low in the nebulae. The pressure in nebulae is far lower than any, vacuum that you could create on Earth, or it was at that time. And so we'd never seen the fact that oxygen could emit what were called forbidden lines. Forbidden lines are forbidden energy jumps in the electrons, and they're forbidden on Earth because the pressure's too high, but they're not forbidden in space. And he made the breakthrough that said, well, what we're seeing is oxygen, not some new element. So Nebulium went into the waste bins, and so it was the periodic table that kind of helped with that. So I think the answer is no to René's last question about will there be elements that we that don't fit into the periodic table.
Okay, well, I'm going to say maybe. I like to be a bit more
controversial.
Yeah. I'd just like to stir the pot. Are we going to keep going backwards, or do you want to?
Yeah, let's go backwards.
All right, quantum computing. What's that going to do for us if it ever gets developed?
So it is clearly will revolutionise the way we handle data because you've got so much more power available in a quantum computer than you have with a standard computer where you've just got binary bits.
Yeah,
1 or 0.
Yeah, my computer, even though it's not very old, is just about capable of adding basic numbers.
So yours has only got zeros; it doesn't have any ones.
It's definitely a 0.
So I think for handling large data sets, clever analysis, things like that, I think that's where we're going to find quantum computing coming to our assistance. Whether it will of itself let us probe the quantum world any deeper, I don't know. It might give us better tools to do that, but in terms of computation, actually calculating things. But whether it's going to give us insights, maybe it will. I don't know. Maybe we'll find out from quantum computing that things in the quantum world don't behave quite as we thought they did. So there is a possibility there, René. It's an interesting conjecture that you read.
It is. He always comes up with those.
He does.
And what if the Earth was a moon?
Yeah, so it would depend, like a lot of these things, the answer is it depends.
Depends what it's orbiting.
Yes, and how far away it's orbiting it.
Yeah.
So we might well find ourselves, if you imagine that we were the moon of a much bigger planet, for example, Jupiter, something like that, we would definitely be tidally locked so that one face would face the giant planet that we were in orbit around. So our month would be the same as our day, as is the case on the moon. There might be other things as well. Jupiter, if you imagine it was Jupiter, Jupiter's got this enormous magnetic field, and there's transfers of subatomic particles between Io, in particular, Jupiter's innermost moon, or innermost large moon, and the planet itself, which is one reason why we get aurorae on Jupiter. Some of the particles come from Io. So there might be phenomena like that would be in the mix as well. So yeah, all kinds of interesting stuff.
Would make your life would be very different, wouldn't it?
It could be. There might not be any life at all, depending on what sort of a planet you were orbiting around.
We'd be a lot shorter.
Yeah, we might be.
Or we might be a lot taller with the gravitational pull. Might be taller.
That's right. It could be the spaghettification that it might do to us. Yeah.
You never know. Interesting, René. Love those what-if questions. Thank you. And finally, from a Twitter, I can't call it that anymore. What's it called? X, from an ex-listener who calls himself Cowboy Tune. Hi, guys. Question for you. How small can a black hole be? If you had a black hole the size of a tennis ball or something, how close could you get to it before noticing its effects, e.g., time passing more slowly as opposed to everyone else? Can they get that small? I know they did some tiny ones at the Large Hadron Collider.
Apparently,
yeah.
Well, it was, that was one of the criticisms when the new improved Large Hadron Collider was switched on, probably 2011 or 2010 thereabouts.
That we destroy the planet.
People saying, "Yeah, you're going to create black holes," so what the Large Hadron Collider did was, on there, I don't know whether you remember this, they had a whole lot of webcams showing, security cameras on the site, and if you clicked on them, you could watch them, and suddenly they'd all start disappearing and getting sucked in because a black hole had been created.
I didn't know they did that.
No, it was very nicely done. And the answer, of course, is that nature throws subatomic particles at us with much higher energies than the Large Hadron Collider could ever create. So they don't produce black holes. So no. But so there is a bit of an answer to this. Now, there is a theory, and it was Hawking actually who basically proposed this, that in the aftermath of the Big Bang, you got a whole series of what are called primordial black holes, which came in all sizes. They weren't just the massive stars; they were all sizes. Some gigantic ones, as well as some little ones, little mini black holes. And in fact, they were for a while postulated as the cause of dark matter, or being the source of dark matter. That these mini black holes were dark matter. What we see as dark matter because there were so many of them. There's no real evidence that happened. It's still a conjecture that people look at and think about. But it's interesting that our ex-listener, Twitter listener, former Twitter listener, postulated the size of a tennis ball, because that, if I remember rightly, is about the size of the event horizon of a black hole of the mass of the Earth. I think it's 18 millimeters.
Wow, there you are.
So
okay.
An Earth mass black hole would have an event horizon the size of a tennis ball. I don't know how far away from it you would have to be before you were immune to its gravitational effects. Probably you could get fairly close before you started getting spaghettified. But I wouldn't trust it, I have to say. If somebody brought me a black hole the size of a tennis ball, I'd say, take it away. I don't want to be anywhere near it.
Just put it in an aluminium box. That aluminium's awesome stuff.
Yeah, or a paper bag.
Or a paper bag. Put the black hole in an aluminium foil container in a paper bag.
Yeah, that would do it.
We'd be fine. But we are learning that there are all sorts of weird and wonderful things with black holes. We've still got a lot to learn about them. We're now able to image a couple of them.
Yeah, that's right.
So we've got a reasonable look. But, so many questions yet to answer about them. So many. But thanks, Cowboy Tuned. Love your question and appreciate you sending it in. Also, thanks to Rennie and Rusty for sending in questions. We've got episode 370 coming up soon, so if you can get some questions into us, that would be great. Just go to our website. I'm going to do that right now, and there it is. Click on the AMA tab. You click on that, and it says, sod off, we don't want to know. But it also says you can answer, you can download your question just by filling in the form, or you can send an audio question. And the other way is to click on the right-hand side, send us your voice message. And voila, if you've got a device with a microphone, easy as pie to send us a question. Just don't forget to tell us who you are and where you're from is what I'm trying to say. Oh, it's been a long day. Yes, it's what is it, 6 a.m.? Gosh, it's all, We're done, Fred. Thank you so much.
It's a great pleasure, Andrew. Always good to talk, and always good to hear these listener questions as well.
Oh, they're great, aren't they?
I
really enjoy them.
Splendid. Yes.
Yep. All right. Take care, Fred. We'll catch you on the next episode.
Thanks a lot. See you soon.
You too. Fred Watson, astronomer at large, and thanks to Hugh in the studio for doing... Yeah, we'll do that next week. And from me, Andrew Dunkley, it's always great fun. We'll catch you on the very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.